Okay, let's do one thing. Find what is the expression for efficiency? Eta A, how you write it? Temperature of cold body, temperature of sink minus 1 minus temperature of sink by temperature of source, no? Temperature of cold body by temperature of body. For engine A, which is out body? This is out body. I think two sinks, you may get confused. So I'll write it, there's an intermediate, I'll write it. Intermediate sink, the engine A, source at temperature. Shall I write body? Sink, you'll get some intermediate body. This will be better. Okay, now this intermediate body, how do you tell? For engine A, intermediate body will behave like a sink, no? Then what is the formula? 1 minus temperature of cold body by temperature of hot body. I think too many symbols will get confused. So shall I write temperature T by T1? So what is intermediate body? Intermediate body will behave as a sink for engine A. That's all, no? Okay, there's the one thing. Similarly, for engine B, what you write? 1 minus temperature of sink by temperature of the intermediate body. So what is intermediate body? How do it will behave? It will behave like a source for the engine B. Will behave as a source. So what is the thing now? So these two efficiencies are equal. So equating these two, what do we get? 1 minus T by T1 T2 by T. So this will be T square. Okay, this is the temperature of intermediate body. It can happen, the source of one body will become the one which is sink. Okay, now are you understanding what do you mean by sink and source? The one source is what? Which will supply heat to engine. What is this? What is a sink? Which will absorb heat from the engine. That's the meaning of sink. Sir, examples of sink. You can take anything. Atmosphere is a good example of sink. No? What is the source? Anything which will supply heat. Able to understand? So these are the types of questions what you can. So small idea that sink and that particular thing is what you should understand. Sink and source. Okay, series, parallel. So like this. So these are the types of questions what we can expect in exam. You make it diagrams not given. I have given diagram. You are supposed to draw it. So they're connected in series means this is the basic idea. Okay, now the Carnot cycle. Again, the second law of thermodynamics is what we can interpret here. So what is the second law of thermodynamics? I think already you know in chemistry. Second law. Let me just second law of thermodynamics. So what it says? It is impossible to build a heat engine Why it is impossible? Because for this to happen, what when temperature of source and sink must be same. I think not possible, no. Then the gas cannot undergo isothermal expansion compression. So in physics, the second law of thermodynamics, in terms of application, I'm writing the thing. So next, again, same thing, second law. No device is possible no device is possible whose sole effect is to transform a given amount of heat I think it's very simple. What is efficiency? When efficiency will be 100%? Why you fight with sentence and English language? No, when it will be 100%? When the whole heat will be converted into work done. Possible? Not possible. No, because what is the equation says? Q positive equal to. Am I right? A part of heat, what all we supply it, a part will be rejected, a part will be used to do mechanical work. So what do you mean by efficiency? When it will be 100%, when W net equal Q positive. So what does it mean? Q negative should be 0. Means when the whole heat supplied converted into mechanical work. No device is possible whose sole effect is to transform a given amount of heat completely into work. Correct? No? I think W net equal Q positive, not positive. W net must be less than Q positive. Okay, there's one thing. Same thing in Carnot cycle, we'll put it. The same sentence for Carnot cycle, we'll write it. Just already we know many things. Just we have to put it in order. That's all. No device is possible whose sole effect is to transform heat from one system to another, from one system at temperature TL to TL into a second system at higher temperature TH. Okay, it can flow from lower temperature to higher temperature? Not possible. Are you getting this one? No device is possible whose sole effect is to transform heat from one system at temperature TL into a second system. This one means, what does it mean? Heat cannot flow from lower temperature to higher temperature. That's what the second law. In physics, what happened? We do interpret second law like this here. Okay, some idea? So shall we take now the next things? Okay, Carnot's heat efficiency, you know formulas and you know the work done and Q positive. The same set of those things. Okay, now let's get into the. Can we define any coefficient of performance for heat engine? Okay, I think I'll come for this one. Okay, let's go for refrigerator. All of you, you know refrigerator in your home. So shall we get into refrigerator working? Tell me, like in refrigerator, what happens? I think you have a better picture about refrigerator. I'll take you to the refrigerator. What actually happens in refrigerator? Anybody? Sir, refrigerator